Quick fact about our neighborhood. The solar system has 8 planets, and none of them are truly alone, except 2. Jupiter has 92 moons. Saturn has 274 moons. Uranus has 29 moons. Neptune has 16 moons. Even Mars has moons. Earth has 1. Now, here's the twist. The 2 planets closest to the Sun, Mercury and Venus, have none. No natural satellites, no companions, just bare worlds orbiting in the Sun's strongest gravitational zone. So why do almost all planets end up with moons, while Mercury and Venus don't? And what does that tell us about how moons form, how orbits stay stable, and how violent the early solar system really was? In this video, we'll break it down in a way that's simple but scientifically honest. Now let's break down the survival problem in a clearer way. It cares what survives, because the solar system doesn't care what forms. It's about whether they can keep one. This isn't only about whether Venus or Mercury could form a moon. And that brings us to the real structure behind the question. But near the Sun, the window becomes much smaller. That window exists for every planet. Too close and they spiral inward, collide, or get torn apart. Too far and the Sun can steal them. They have to stay in a narrow orbital window for a very long time. Moons are delicate in the one way that matters. The inner region is where the Sun's gravity is strongest, where orbits are faster, and where the early solar system was a more violent place to try to keep anything delicate. That's why the inner planets tell a very different story from the outer planets. They're evidence of how that planet formed, what it collided with, and how stable its orbital environment has been since the beginning. In reality, moons are evidence, like a bonus feature. People often think moons are decorations a planet collects. Before we go deeper, it helps to correct one common mental picture. What are satellites? A natural satellite is a smaller body that orbits a larger one, typically a planet, in a stable, repeating path. They're not the artificial satellites used for GPS or Wi-Fi. These are natural objects shaped by gravity and time. How do moons form? Moon formation is a byproduct of planet formation, and it can happen in a few main ways. 1. Giant impact. A major collision throws material into orbit, which later clumps into a moon. 2. Capture. A planet gravitationally captures a passing object, locking it into orbit. 3. Co-accretion. Moons form from leftover material in the planet's surrounding disk as the planet forms. 4. Fission. A rapidly spinning young planet sheds material that can become a satellite. Different moons can form by different pathways. Some are round and regular. Others are irregular, small, and chaotic. Clues that capture played a role. Not just forming moons, but keeping them from being stolen or destroyed. Which means Mercury and Venus are fighting the same war from the start. Doing it where the Sun's pull is strong makes the orbit easier to disrupt. Capturing an object into a stable, long-term orbit is already difficult. Capture is also tougher near the Sun. If the zone is too narrow, the debris can disperse, fall back, or be pulled away before it ever becomes a moon. But a moon born from impact debris still has to live in a stable orbital zone. Earth is the proof. Giant impacts still happened, and when they happen, they can create moons. That makes stable moon-building disks harder to maintain. Material was hotter, more scattered, and the Sun's gravity shaped everything more aggressively. In the inner solar system, conditions were different. Those disks make co-accretion common, moons forming alongside the planet from leftover debris. In the outer solar system, giant planets formed with thick disks of material around them. And these formation methods aren't equally likely everywhere. But there's a catch. Forming a moon is not enough. A moon has to stay in orbit for billions of years without being pulled away by the Sun or smashed into the planet. That stability depends on gravity and distance, specifically how large the planet's gravitational neighborhood is compared to the Sun's pull. Mercury, too close, too small, too unstable. Mercury is the smallest planet in our solar system, only slightly larger than our moon. It's also the closest planet to the sun, and it moves fast through the strongest part of the sun's gravity. Mercury takes 88 Earth days to complete one orbit around the sun. Here's the core problem. Mercury's gravitational safe zone for moons is tiny. If a moon orbits too far out, the sun's gravity can steal it, tugging it into a solar orbit. If a moon orbits too close in, it risks spiraling down and colliding with Mercury. So even if Mercury briefly captured a moon, or even if an impact created debris around it, the orbit would be difficult to keep stable over a long time. The sun's pull dominates that region. Mercury's mass isn't enough to hold a wide, long-lived satellite system. It's the expected outcome of a small planet living in the sun's strongest gravitational territory. That's why Mercury being moonless is not a coincidence. And because Mercury's stable zone is narrow, there's very little room for a moon to wander without crossing a boundary into instability. Gravitational tugs from the sun reshape orbits slowly but relentlessly. Even small nudges add up over time. It has no large gravitational reach compared to the sun in that region. It has no thick atmosphere to create drag and stabilize debris into a long-lived disk. Mercury can't provide that correction. It's impossible to keep it there without constant correction. It's not impossible to place it there for a moment. Think of Mercury's situation like trying to hold a marble in orbit while standing next to a powerful magnet. Venus, the sun's influence, plus a second complication. Venus is the second planet from the sun and the third brightest object in our night sky. It's also the hottest planet, not because it's closest, but because its atmosphere traps heat so efficiently. Venus has a larger gravitational reach than Mercury, but it still sits deep inside the sun's strongest zone. That makes stable moon orbits much harder than they are for Earth, Mars, or the outer planets.
There's also an additional complication. Venus's rotation is unusual, and its long-term dynamical history likely included intense gravitational interactions and impacts. In other words, even if Venus once had a moon, it may not have kept it. A moon can be destabilized, slowly pulled away, or eventually lost, especially when the sun's gravity is competing so strongly. The honest answer is, Venus couldn't keep one. That's why the most honest answer isn't, Venus never had one. Those are the easiest to lose when the sun is competing for control. And even if Venus captured a passing object, capture produces strange, fragile orbits. If Venus formed a moon through impact debris, that moon would still need to avoid being pulled into a solar orbit or pushed into Venus over time. The inner solar system went through phases where impacts were common and orbits shifted. On top of that, Venus's long-term dynamical history likely wasn't gentle. And Venus doesn't get a wide region like Jupiter or Saturn does. A moon has to remain in the thin region where the planet's gravity dominates more than the sun's. Near the sun, stability is expensive. They're held by orbital stability, but moons are not held by atmosphere. It has plenty of gravity to hold on to an atmosphere, and it does, in the most extreme way. It's closer in size to Earth. Venus looks like it should be the exception. Why Earth kept a moon, and why that matters. Earth is far enough from the sun that its gravitational neighborhood is larger and more forgiving. And the leading explanation for our moon's origin is a giant impact early in Earth's history, a collision that produced orbiting debris that later formed the moon. The moon is thought to have formed about 4.5 billion years ago, not long after Earth itself. Once a large moon exists, it can also stabilize a planet's tilt and influence long-term climate patterns. So the presence or absence of moons isn't just a trivia fact. It changes how a world evolves. So why don't Mercury and Venus have moons? Because in the inner solar system, the sun's gravity makes it much harder to keep moons in stable orbits. Mercury is small and extremely close to the sun, so its stable zone is tiny. Venus is larger, but still close enough that the sun strongly competes, and its history may have removed any moons it once had. The deeper takeaway is this: moons are not guaranteed. They're the survivors of chaos. They're a map of where the solar system is forgiving and where it isn't. And once you see that, you realize the moon counts are more than trivia. They're telling you what the inner solar system is really like. They aren't broken. Mercury and Venus sit at the extreme end of that trend, and why the inner planets are sparse. That's why the outer planets can host huge families of moons. The closer you are to the sun, the harder it is to keep moons long-term. So if you're looking for the simplest rule behind the pattern, it's this. They're what remains after impacts, captures, and gravitational battles play out over enormous timescales. Speaking of Venus, there's something even stranger about our neighbor. It rotates backwards, and so slowly that one day on Venus is longer than its entire year. Watch our video on why Venus rotates differently from other planets to discover the violent history that turned this world upside down.